Hey, if you thought time travel wasn't possible for you, well, think again. On today's What If Marathon, we're going to take you on a journey back to the beginning of time. We're covering everything from the Big Bang to human evolution, so stick around for the next few billion years or so as we reshape the history of humankind. But before we start, I got a bit of a trivia question for you. When did the Big Bang happen? Was it A, 12 billion years ago, B, 14 billion years ago, or C, 16 billion years ago? Well, strap into the time machine and hang on because we're sending you back to the Big Bang right now. In the beginning, there was nothing. Well, except for you. And the Big Bang. What would the first moments of the universe be like? What would happen over the next thousands of years? And would anyone believe you? This is What If, and here's what would happen if you were alive during the Big Bang.
Who wants the last dumpling?
The Big Bang Theory. No, not the TV show. I'm talking about the most popular story about the earliest moments in the history of the universe. According to this theory, the universe emerged from a single point nearly 14 billion years ago. This point, known as a singularity, would have been infinitely dense. From this singularity, the entire universe expanded, eventually cooling down enough to form stars, galaxies, and planets like the one you are on now. And our universe is still expanding today. That's one of the most compelling pieces of evidence supporting the Big Bang Theory. So let's travel back to a time where it all began. In order to learn more about these hypothetical scenarios, I've been binging the series Secrets of the Universe over on Magellan TV. This series covered a lot of different topics that I've always been curious about, like what's on the other side of a black hole and how moons are formed. And I gotta say, these episodes were absolutely stunning. They produced visualizations of these topics in ways I've never really seen before. You get to see simulations of these cosmic events, and they're all backed by real science. It definitely kept me watching more. Then, when I was done with Secrets of the Universe, I watched a bunch of other space documentaries, of course. Ones about exoplanets, space colonies, and solar storms. If you like anything about what we do here at What If, well, you're gonna love Magellan TV. They've got so many high-quality documentaries about space, science, tech, and more, both entertaining and educational. Plus, they drop new stuff every week. So if you want to watch Secrets of the Universe and thousands of other documentaries on Magellan TV, well, click on the link in the description. You can get a 30-day free trial for your watching and learning enjoyment. Set your coordinates to 13.82 billion years ago. Time to take your shiny new time machine on an epic spin into the past. What you'd find when you arrived would be, well, nothing. You and everything you've ever known no longer exist. But by some miracle of your time machine/spaceship, you'd arrive at the exact moment of the Big Bang. Before this moment, all the particles that make up the universe were crammed so tightly that not one atom could even form. In this state, the density was infinitely higher than the matter in our current universe. Right after the Big Bang occurred, this matter existed in the form of quark-gluon plasma, or QGP. Very quickly, in a matter of milliseconds, the particles making up this QGP would clump together to form the protons and neutrons that make up the atoms we know today. According to astrophysicist Paul Sutter, At this point, everything was crushed into a ball about the size of a peach. This ball would have been very hot. How hot? Well, only like 1,000,000,000,000 Kelvin. That's like 999 billion degrees Celsius. And I wouldn't blink if I were you, because if you did, you'd miss the universe rapidly inflating from the size of a basketball to roughly the size of the sun. Particles would be flying through the QGP at velocities higher than the speed of sound. Like a jet traveling at Mach speed, these particles would emit a supersonic boom. Of course, you wouldn't hear anything. Sound can't travel through the vacuum of space. Not to mention, you'd be witnessing a time before any matter has formed. And sorry to say, you'd barely be able to see anything either. Everything would look foggy and blurry. The super dense plasma would scatter light, similar to water droplets in clouds. 1 microsecond after the Big Bang, you'd see neutrinos, quarks, and electrons form. Shortly after that, you'd see protons and neutrons forming. This would all be happening within 1 second. At this point, the temperature of everything would have dropped to a chilly 5.5 billion degrees Celsius. And after about 3 minutes, things would have cooled down enough for these protons and neutrons to form hydrogen nuclei. You'd now be witnessing the era of nucleosynthesis. But don't get ahead of yourself. You wouldn't see the first elements form for another 380,000 years. All those years later, the universe has finally expanded and cooled enough for electrons to stay in orbit around an atomic nuclei. The first hydrogen and helium atoms would form. You'd finally be able to see things more clearly, too. Okay, now you've reached the point in our creation timeline that scientists have some evidence of today. Cosmic microwave background radiation, or CMB, is leftover radiation from about 400,000 years after the Big Bang. These microwaves are invisible to the naked eye, but they reveal that there was a time when the universe was both hotter and denser. More proof that scientists point to in favor of this history of the universe is the speed that galaxies appear to be moving away from us faster than those closer to us. This would suggest that there was a time when all galaxies were in the same spot. Yeah, the singularity. Of course, you would have witnessed all this firsthand, but without bringing back any definitive proof, the Big Bang would still remain a theoretical model of the history of the universe. There would still be so many unanswered questions, and even if it was all true, would that really have been the beginning of everything? Stars are gigantic balls of fire holding planets, asteroids, and meteorites in their firm gravitational grip. And their fire sends light into the farthest reaches of their galaxies. But how did they get here? I mean, these incredible orbs must have come from somewhere, right? What would it be like to witness this epic birth? What would it feel like at the center of the action? And why would this beautiful event have a funny smell? This is What If, and here's what would happen if you saw a star being born. The Milky Way galaxy spans about 100,000 light years across, and it contains somewhere around 200 billion stars. If there are that many stars in our little section of space real estate, imagine how many there are in the entire universe. Now, depending on where you look in the night sky, you could see around 5,000 stars just with your naked eye. The brightest ones have melodic names like Polaris, Alpha Centauri, and Betelgeuse. Looking further out into the universe with the help of telescopes, there are simply too many stars to name.
That's the North Star. Well, what is that?
That's why many of these are now identified more generically, like WASP 50, HD 28678, and HAT P23. But today, you're not just going to look into a telescope and name some baby stars. You're going to be in the thick of it. The hot, dense thick of it. Every year, 7 new stars are born in the Milky Way alone. Now, that might not sound like a whole lot, but keep in mind that our galaxy has already used up 90% of its star-making material over the billions of years of its existence. And yet, new stars are still being born all the time. Now, to witness their birth, you need to travel to one of the many star nurseries in the universe. These are known as nebulas. Nebulas are huge clouds of gas and dust that can span light years across. So, hop into your interstellar spacecraft and set your coordinates for one of the most famous stellar nurseries of our galaxy, a mere 1,344 light years away, the Orion Nebula. Yeah, it's here that you'd find the necessary ingredients for a star to be born: gas, dust, gravity, and turbulence. Sounds like my car. Being in the middle of a nebula would feel like being in the clouds. You'd be surrounded by over 200 different kinds of molecules. There would be hydrogen and helium gas, as well as microscopic grains of silicon and iron. And I hope you packed some warm clothes because conditions in this cloud would be frigid. You'd need a spacesuit thick enough to withstand temperatures as low as minus 270 degrees Celsius. But don't worry, things are about to heat up. Suddenly, you'd be hit by a blast. This would be a ripple effect from an exploding nearby star, and it would cause the nebula to become turbulent. All it means is that the gases around you would start to mix and swirl together. It would be the beginning of the epic event you're here for. First, dust particles would begin to clump together. These clumps would become denser and denser, forming knots. Once these knots gain enough mass, they'd start to collapse under their own gravity, and their internal pressure and temperature would increase. Yeah, at around 2,200 degrees Celsius, these high-pressure knots would emit a dull red glow. You wouldn't be able to see it because that light would be infrared. Oh, but you would be uncomfortably aware of the temperatures starting to rise. And things would keep heating up. Eventually, the protostar before your eyes would emit its first rays of visible light. Wait, do you smell that? Well, no, of course you don't. You're wearing a heat-resistant spacesuit, but if you could, you'd learn that this hot mass of dust and gas would also smell.
It's disgusting.
But not necessarily in a bad way. Depending on the mixture of compounds around you, you could detect hints of sweetness, lemon, or even alcohol. But be careful, your baby star wouldn't only be pulling things inward. Every now and then, it would shoot powerful jets from its poles at supersonic speeds. These would flash brightly as they come into contact with the surrounding gases. All the while, the protostar would simultaneously grow and collapse under its own weight. This would make the core continue to heat up. Yeah, once it reached the scorching hot temperature of 5 million degrees Celsius, you'd witness your baby star's first nuclear fusion. Deep within the center of the star, 4 hydrogen atoms would fuse together to form helium. This would release a ton of energy. And with all that energy, the protostar's pulsations would come to a halt. It would finally become a star. Now, during the excitement of witnessing a star being born, you'd have seriously lost track of the time. If the star that formed in front of your eyes was similar to our sun, well, you'd have just watched 50 million years fly right by you. And you might want to get your hearing checked after experiencing all this. Of course, there's no sound in the vacuum of space, we all know that, but in the stellar nursery filled with gas and dust, sound waves may have a medium to travel through. And if you were wondering what the birth of a star sounds like, well, it would be deafening. If we could hear our own sun, it would be a lot like Earth was covered in constantly wailing sirens, except multiplied by 10,000. A new star created by a series of violent contractions of superheated gas? Ugh, forget about it. Okay, now that your baby star is all stabilized, it could burn bright for another 10 billion years. Okay, going back to our trivia question, if you said the Big Bang happened 14 billion years ago, well, you're correct. I mean, technically it was 13.8 billion years ago, but let's round up. Are we really going to nitpick over a lousy 200 million years in the grand scheme of things? Now, I hope all this time travel isn't making you dizzy. Honestly, you should be grateful. They never send me on these cool trips. I'm always just watching from above and narrating everything. You know, there was a time when fancy trips and overseas travel wasn't a thing. That's because we used to be one giant landmass. That's right, at one point in history, we were all neighbors. Well, kinda. All the continents used to be connected, so you didn't necessarily need to spend days traveling from one point of Earth to another. You know what? I'm choosing your next mission. You're going to go back in time and make sure Pangaea doesn't fall apart. What could go wrong? I'm sure all the new neighboring continents will get along just fine. Or will they?
Millions of years ago, the Earth looked very different. A huge landmass called Pangaea covered about a third of our planet. But about 175 million years ago, the Earth broke up into continents and formed the world we know today. What if that had never happened? Where would your country be located? And how different would your life be? This is What If, and here's what would happen if Pangaea had never broken apart. If Pangaea existed today, in theory, you could drive from California to England, since they'd both be part of the same landmass. And although you may only think of Pangaea as just another piece of land, it would be much more than that. It's played an integral part in human and animal evolution. If Pangaea had not broken apart, you may not be here today. But let's assume it didn't, and that we survived and evolved to be the people we are today. What would the Earth be like? First, let's talk about where your country would be located. North America would be right here. Europe would be a lot closer, just to the east. Asia would be up north by Russia, and Antarctica would remain down south. India and Australia would be further south, connected to Antarctica. These countries that used to have hot climates would now be cold, covered with snow and ice. And those wouldn't be the only environmental changes. Regions in the middle of Pangaea would have lush rainforests along their borders. And as you travel further inland, it would become a desert. This would be due to Pangaea's landmass being so large. Rain, which comes from the ocean, wouldn't be able to travel far enough inland, leaving parts of Pangaea practically uninhabitable by humans and other species. And weather up north would be different too, with Russia being much warmer than it is today. But the weather wouldn't be the only thing that would change. On Pangaea, we might have less diversity of species. The species at the top of the food chain today would most likely remain there, but some of today's animals would not exist in Pangaea. They wouldn't have the chance to evolve. Fewer animals might make it easier to travel, and on this modern version of Pangaea, you'd probably want to do a lot of it. Luckily, you wouldn't have to go far. If you lived in Florida, you'd be right next to the Caribbean islands, Venezuela, and Brazil. You could visit all of these in a single day. And if you lived in Nova Scotia, Canada, you'd be driving distance from France, England, and Germany. Although this might sound like fun, a lot of countries would have new neighbors, which could cause some serious issues for some. Places like the United States, which used to have oceans on both sides of the country, would now have Africa on its east coast. If these countries didn't get along, things could get ugly. How much easier would it be to start a war in another country if they were just a short drive away? Transporting weapons, people, and supplies would all be faster and cheaper if certain countries were right next to each other. Or none of this would happen and the entire world would be more unified than ever. With all of us sharing the same landmass, maybe we'd learn to treat each other just a bit better than what we do now.
Okay, power up the What If Time Machine because today you're traveling back to witness the most radical changes ever known in Earth's history. You'll watch our planet give birth to strange new animals and see continents taking shape. We're going to the time that defines our existence, the Paleozoic era. But how would your body react to the new climate? What kind of creatures would you eat? And how hot would the planet get? This is What If, and here's what would happen if you lived in the Paleozoic era. The Paleozoic era began 530 million years ago, when the Earth woke up from an ice age. The era lasted for 289 million years, but you might not even last 5 minutes in this climate. But hey, if you're as resilient as the life in these waters, you just might stay alive. In these oceans, life has the perfect space to begin. And like all great things, it started small. Good luck trying to find a meal. 543 million years ago, all life on Earth lived below a thick layer of mud on the sea floor. But don't get out your lobster bib yet. The only things you'll find here are microbes. Ooh, so chewy. Your menu won't be getting any bigger for a few million years, until the Cambrian explosion, the big event that would kickstart life on Earth. The cyanobacteria would pump more oxygen into the atmosphere, making it easier for you to breathe. So take a deep breath and enjoy life on this doomed continent. During the Ordovician period, 485 million years ago, you would watch North America and Europe merge to become the supercontinent known as Gondwana. Now, grab your parka because as this landmass moves over the South Pole, a massive ice age would spread across the globe. Under the water, jawless fish would roam the sea, dominating the ocean. Algae and sponges would begin living on coral reefs, and back on land, the first plants would take root. But 80% of the life in shallow seas would die as sea levels plummet when the new ice age begins. Starting about 444 million years ago, you would see the glaciers melt. This event would create a climate similar to what we have now. The ocean would be full of sea scorpions, the size of dogs. So look out, these opportunistic predators may confuse you with dinner. In the Devonian period, 3 continents blanketed the planet. 419 million years ago, much of Earth's landmass remained underwater. You would need to live near the shoreline to harvest the resources you need to stay alive. Since trees would be covering the world for the first time, you could build shelter and even start a fire. And with the soil rich in nutrients, you could begin to farm plants. But while you would rule the land as an apex predator, the ocean would belong to the early sharks, and they look hungry. Travel back 358 million years ago, and you would see life near the equator would thrive while the rest of the world would experience deadly temperature changes. The first reptiles would start appearing. Look out for that ophiuchodon. They can grow almost 3 meters tall. Even dragonflies can have wingspans of 75 centimeters. Well, one of those could feed you for a while. Okay, all the changes we saw have led to this event, the Permian period. About 299 million years ago, almost every landmass on Earth had merged into the supercontinent known as Pangaea. This massive land stretched from pole to pole, with vast deserts in the center. The wild temperature changes would kill amphibians, but don't worry, you wouldn't be alone here. The Archaeops would tower over you, standing 2 meters tall. This lizard-like creature devoured its prey whole. If you keep out of its way, you might enjoy the new oxygen levels, thanks to more trees sprouting up everywhere. But you would see a violent end to this period. Whether it's meteors, exploding volcanoes, or methane clouds, 96% of all life on Earth would die out. The highest extinction rate ever known. Now, if you made it through, get back in the time machine. You know, when I was a kid, I was never really interested in having a pet dog or cat like the other kids, not even a goldfish. No, I was dreaming of a pet pterodactyl. You know, those huge prehistoric bird dinosaurs with huge beaks and blood-curdling screams. Yeah, imagine flying through your city on one of these. I was kind of a weird kid. But today, we might be making my dream a reality because we're going to find out what would happen if the dinosaurs never went extinct. Did you know that scientists have found dinosaur DNA in our water? So, in a way, they're still with us. Before this next episode, grab yourself a nice cold cup of dino DNA and we'll talk about why they went extinct and how we could have lived in a reality where we coexisted with them.
How cool would it be to see a real-life T-Rex? If only that one fatal asteroid never hit the Earth. Would dinosaurs still be alive today? Would they have evolved? Would humans have survived this long? Could we ever learn to coexist? This is What If, and here's what would happen if dinosaurs never went extinct. Until 66 million years ago, dinosaurs of all shapes and sizes roamed the Earth. Intelligent, adaptable, and sometimes weighing as much as 2 jet planes, it's hard to believe that it only took one rock to wipe them all out. Of course, this was no ordinary rock. The asteroid that took out the dinosaurs was 9 miles wide and hit Earth with the destructive force of 10 billion Hiroshima bombs. The radioactive shockwave obliterated everything for hundreds of miles in every direction, and 75% of all species on Earth went extinct. If that asteroid had hit just a little earlier, a little later, or even a few miles off course, we would be living in a very different world today. The rock that killed the dinosaurs struck the shallow waters of Mexico's Yucatan Peninsula. Had it landed a little farther off the coast, in a deeper part of the ocean, the water might have absorbed some of the blast, along with its devastating effects on the atmosphere. But even if the asteroid missed the Earth, dinosaurs would have to survive several significant global events in order to make it to the present day.
55 million years ago, temperatures rose. The climate was 8 degrees hotter than it is today. Rainforests sprouted and vegetation flourished. Herbivores would have adapted and thrived, but they'd have started to look a little different. The plants of this period were less nutritious and easier to digest, meaning dinosaurs would likely shrink in size, since their new diet wouldn't have as much energy.
Roughly 20 million years after that, South America and Antarctica split, creating a cooler and drier world climate. During this period, long-legged, fast-moving dinosaurs would have evolved to travel the huge grasslands stretching out across the globe. Compared to mammals of this period, dinosaurs held significant advantages, such as having more teeth and better eyesight. Considering the dinosaurs were already so advanced, scientists wonder whether mammals would have evolved at all if dinosaurs hadn't gone extinct. It's likely that the big animals we know today would have been prey to dinosaurs. But remember, humans evolved alongside woolly mammoths and saber-toothed cats. While those species didn't survive the ice ages of 2.6 million years ago, given the evolutionary traits of some dinosaurs, there's a chance they might have persisted. But what about us? Could we handle freezing temperatures and huge, terrifyingly vicious predators? They say running keeps the body warm, but that might also make you taste better. In an alternate universe, if we did survive alongside these prehistoric beasts, it's possible we could see a real live T-Rex on a protected reserve, not unlike Jurassic Park. Human population growth and excessive hunting would have driven larger dinosaurs to near extinction. Today, they would most certainly be an endangered species, but those that shrank and adapted over millions of years could coexist peacefully among us. In fact, some actually do. Where do you think pigeons came from? It's hard to believe that birds were once the size of biplanes, but then again, it's hard to believe that with a slight twist of fate, we might have walked with dinosaurs. Or we might have become dinosaur chow and not have evolved at all.
What was life like in the Cenozoic era? Welcome to one of the most formative and terrifying time periods ever, the Cenozoic era. You'll find giant creatures like woolly mammoths and megalodons roaming the seas, along with some other creatures you might be a little bit more familiar with, but more on that later. Let's strap in and travel back in time to the Cenozoic era. How would you survive during this period? Why was Earth so dangerous? And how is this era similar to modern day? This is What If, and here's what would happen if you traveled to the Cenozoic era. Okay, you're now 66 million years in the past. You just missed the age of dinosaurs by a couple of million years. They were wiped out by a giant asteroid and are now extinct. But that doesn't mean that other life hasn't found a way. The death of the dinos made way for new creatures to emerge. Mammals. Yeah, the early Cenozoic period saw the rise of primitive mammals that would begin to diversify into different evolutionary niches. Let's explore and check them out. One of the most famous mammals during this time was the megafauna. These were giant creatures that roamed the earth. A lot of these probably look familiar. Go to the colder regions of the earth and you'll find packs of woolly mammoths roaming about. These guys were nearly 3.5 meters tall and weighed up to 8 tons. Okay, go over to what's now known as Australia and you'll see the Diprotodon. This is the biggest marsupial that ever lived and looks like a giant wombat. And it wasn't just the mammals that were giant. Watch out in the water because you'll be met with one of the most terrifying creatures ever, the megalodon. This giant shark dominated the oceans with teeth as big as 18 centimeters and a body as long as 20 meters. I could go on, but we have so much more to explore. Let's check out a couple of other creatures and then I'm going to show you something really cool. The Cenozoic era also had the Glyptodon, which was like a giant armadillo, the Megatherium, a giant sloth and one of the largest of the mammals, and the Elasmotherium, also known as the Siberian unicorn. It was basically a woolly version of a rhinoceros. And there were a bunch more creatures. But why were they all so big? Well, researchers have several different theories as to why these creatures became so massive. One of the leading ones is that with the dinosaurs gone, these mammals could thrive in open habitats, helping them grow larger and larger as generations progressed. But there's another incredibly important mammal I haven't mentioned yet, and although it's not a giant, it is one of the most important. And that's you. Well, sort of. Humans' early ancestors were primates. With the death of the dinosaurs, the rise of primates became possible, allowing them to evolve. Early primates were small and weak creatures when the Cenozoic era started, but they had two key features to help them become dominant: grasping fingers and forward-facing eyes. Over millions of years, they survived and later thrived on Earth. This led to primates diversifying and the emergence of different species, which then gave us two main groups: the primates, who would later evolve into monkeys and apes, and the hominids, who would later evolve into humans. But this wouldn't happen for millions of years. As the Cenozoic era progressed, hominids learned how to use tools, control fire, and develop the beginnings of early language. As more and more hominids appeared, they spread globally and could be found in Asia, Europe, Africa, and North America. Some of these species died out, specifically the Neanderthal. They evolved outside of Africa and adapted to live life in Eurasia, but as modern humans progressed, they were more technologically advanced, eventually leading to the extinction of the Neanderthal. As more and more species of hominids evolved, more and more died out. The only ones to survive were the Homo sapiens, who stayed in Africa. Their brains continued to grow, leading to more advanced language, technology, culture, and eventually you. Speaking of you, how would you survive in this era? Well, to do that, it'd be helpful to know what the Cenozoic era was made up of. After all, it spanned tens of millions of years and a lot of stuff happened. The Cenozoic era is divided into three time periods: the Paleogene, Neogene, and the Quaternary period. Let's quickly break them down. Paleogene period. This marked the start of the Cenozoic era. The mammals we've been talking about, along with flowering plants, have begun to emerge. Oh, and watch out for some creepy-looking insects. Earth's tectonic plates continued to shape continents, as they have been for many millions of years. South America and Africa would continue to move apart, and the Himalayas would begin to form. You'd notice a generally warm and comfortable climate, but that would start to change as you move into the next era. Neogene period. Okay, the hominids we've been talking about have now appeared, and more modern plants and animals have begun to evolve. One of the main things you'll notice is how much colder it's getting. Ice ages are becoming more common during this period. Quaternary period. This period had multiple ice ages and interglacial moments. The Earth cooled down and heated up several times. Humans, along with the large mammals we mentioned earlier, had more impact than ever before. This period is also known as the Anthropocene, which recognizes the significant impact humans had on the Earth's ecosystem and geology. So, how would you survive during these times? Well, it would be much easier than if you were to live in a time period even further away. Hundreds of millions of years ago, Earth had more oxygen, which would make breathing more difficult. But luckily, you don't need to worry about that. You just have to be wary of the giant animals trying to kill you, the unpredictable weather, and the weird kinds of foods that could make you sick. Sounds easy, right? Hopefully, you'll be able to cozy up with some early hominids and join their tribe. They'll have access to shelter, fire, and tools. And
If you can't manage to do that, well, find a cave, make a fire, and hope for the best. But wait, you're technically surviving in the Cenozoic era right now. Yeah, that's right. This era hasn't ended yet. We're currently living in the Quaternary period. Eras on Earth are typically marked by major geological shifts or mass extinctions, neither of which we've had to deal with, luckily. Folks, are you like me? Have you ever looked at a chimpanzee and thought to yourself, are we absolutely sure humans came from them? Well, human evolution is a little bit more complicated than that, so you have the right to be confused about it. One of the many things that make humans so special is our consciousness, our awareness of life and existence, and expenses and the future. Have you been planning for the future? Have you set aside any money for your retirement? It's never too late to start thinking about it. Philosophers debate how we could possibly have such self-awareness if we evolved from the same animals we see in the wild. Some credit the start of human consciousness to a certain drug. Keep watching to find out which drug they're talking about, if all humans are related, and where we drew the line between apes and being human. Asteroids, volcanoes, a lack of oxygen. These were just some of the ways that life was almost snuffed out on our planet. But against all odds, humans have managed to survive. So how did we go from tiny molecules to taking over the entire world? Well, we'll take you on a journey through time that explores the evolution of humans in 20 minutes. Who the heck is Luca? Is it evolution's fault that we're all wearing braces? And wait a minute, do we all really have the same great-great-great-grandmother? 4.5 billion years ago. 4.5 billion years ago, something absolutely mind-blowing happened. And I'm not talking about the Big Bang. Believe it or not, this second act might be even wilder. I'm talking about abiogenesis, the beginning of life from non-life. Imagine a soup of ammonia, methane, and hydrogen in a hot broth of water. This could be cooking in a volcanic vent deep in the ocean. Instead of curry powder, Mother Earth probably added some sulfur, nickel, and iron to the broth. Molten rock underneath then heated things up. Over millions of years, these molecules clashed together to form chains of amino acids like lysine, lactic acid, and urea. These may have been the building blocks of life. In the end, some of these chains started replicating, and voila! Molecules became replicating cells. We now have life on Earth. Okay, it's probably not that simple, but this was roughly how the very first single-celled organism came to be. Probably in a deep-sea hydrothermal vent. Meet Luca, the last universal common ancestor. Humans, animals, fungi, not-so-fungi, trees, we can all trace our existence back to this critter. One of the countless differences between modern humans and our friend Luca here is that he was not self-conscious. And while we may have tons of information on how we developed our big brains and started walking on 2 feet, our leap to self-consciousness is still a little mysterious. Let's take a moment to explore this a bit further because there's some pretty wild ideas out there. Some philosophers have even proposed that the key that unlocked our self-consciousness was psychedelic mushrooms. Yeah, the theory goes that our ability to use language, reflect on ourselves, and perform other unique human brain functions might all stem from ancient ancestors who consumed psilocybin mushrooms. These psychedelics are known to de-pattern the brain, alter modes of perception, and encourage social bonding, which could be the perfect ingredients for the emergence of human consciousness. And if you're doubting the power of these little mushrooms, all you need to do is look how they're being used today. One biopharmaceutical company called Cybin is using them to solve one of humanity's biggest problems, depression. Depression is a chronic illness that affects 280 million people worldwide, and it costs the global economy $1 trillion each year in lost productivity.
Cybin is developing safe and effective psychedelic-based therapies with top partners, creating scalable synthetic psilocybin for inpatient depression treatment. Instead of the bandage solution of antidepressants, which just numb the symptoms through daily use, Cybin offers a long-term fix in just a couple of doses. Now, this might sound like something from the future, but the company's already gaining traction. They got the FDA's Breakthrough Therapy designation, which means a fast track for their drug development process. This is the first known time the FDA has granted this status for a psychedelic-based therapy for major depressive disorders. Cybin recently had no issue raising $150 million in capital, and following a positive FDA meeting, they're set to launch phase 3 trials in the US and Europe, with all clinical supplies ready to go. It's pretty wild to think that the same mushrooms that are healing our minds today may have played a key role in shaping them in the first place. But we're getting a little ahead of ourselves. In order to be self-conscious, we need a brain first. So let's get back to our timeline. 3.5 billion years ago. Before we humans can enter the scene, we need one very important thing, and that's oxygen. Earth used to be full of nitrogen, hydrogen, water vapor, and carbon dioxide. It wasn't until cyanobacteria came along that we got the precious oxygen that we humans need. 1 billion years ago. Fast forward to 1 billion years ago, when Earth was shifting around, creating different supercontinents. You had Rhodina, and then a couple of 100 million years later, another supercontinent, Pangaea, formed near the South Pole. This was also a time when single-celled organisms were starting to form into the first simple animals. 550 million years ago. 550 million years ago, one of the most critical events in our history took place, the Cambrian explosion. This is when hundreds of different animals burst onto the evolutionary scene. It was the building block for every major animal we know today, including you. 66 million years ago. The dinosaurs ruled Earth for hundreds of millions of years and survived multiple extinctions, but all good things eventually come to an end. 66 million years ago, an enormous asteroid hit Earth, landing on the Yucatan Peninsula in today's Mexico. It coughed up a ton of debris, blocking the sun. This finally wiped out the dinosaurs. This might seem like an insignificant event for us humans, but this extinction opened up the spot for mammals to become the leaders of the animal kingdom. 40 million years ago. These mammals included small, furry ancestors of all primates. The early primates were similar to the small rodents we see today. They lived and multiplied in a unique ecological niche, eating an omnivorous diet of fruits and insects. They continued to evolve, and their brains grew bigger. Without competition from the dinosaurs, they were able to grow exponentially. After millions of years of evolution, monkeys were seen in Africa, Asia, and South America. Fast forward another several million years, and apes evolved. Then the orangutan lineage split off. Soon it would be our turn. 8 million years ago. Then, about 8 or 9 million years ago, human, a common ancestor to both chimpanzees and humans, split into two lines, chimpanzee and human. For a long time, biologists thought this was a clean split that created separate chimpanzee and human species, but they were wrong. The two lines continued to mate and exchange genes for millions of years. It may have taken a full 4 million years before the two species fully broke from each other. Even today, though we're a different species, humans share an astonishing 98 to 99% of our genes with chimps. So, 5 to 6 million years ago, the Homo genus became distinct. Despite being a separate line, our ancestors were still pretty ape-like. You may have heard of Lucy, a 3.2 million year old ancestor from Ethiopia. Her brain was tiny, chimp-sized. The secret to big brains had yet to be discovered. And Lucy had long arms. She probably spent a lot of time swinging in the trees at night. But there was one important feature that separated early humans, including Lucy, from apes. We were bipeds, walking on two legs. What led to that? Well, there are two explanations for what got humans walking upright. The first is the savanna hypothesis. According to this, when forests retreated and savanna spread, humans spent more time foraging among the grasses, and walking upright allowed them to see better, like an SUV that towers over all the sedans. However, after studying chimps in western Tanzania, some scientists believe early humans mostly walked upright in trees. This may have been to gather fruit in the upper branches or to escape predators, but this theory has got some explaining to do. For instance, it can't explain why humans became bipeds but chimps didn't. Then how about them kangaroos? 2.6 million years ago. About 2.6 million years ago, early humans started getting the hang of things. Their brains began developing further, which allowed them to start making tools. The species behind this was Homo habilis, sometimes known as handyman. The early tools were only sharpened stones. It took another million years for humans to make hand axes, but we'll get to that in a bit. Scientists don't believe these early humans were fearless hunters. They were probably mostly scavengers, eating leftovers from kills of saber-toothed tigers. They used their tools to cut up carcasses and break bones to get to the nutritious marrow. If they got lucky, they also ate zebras, elephants, rhinos, buffalo, and giraffes. But mostly, they were just eating salad. It's no surprise that early humans weren't all that fearless. Life was dangerous. We see some pretty gruesome deaths in the fossil record from 1 to 2 million years ago. One adolescent was caught by a leopard and dragged up a tree. A 3-year-old was likely picked up by an eagle with its talons digging into the child's skull. And if it wasn't a leopard or an eagle, gum disease might get you. One kid got an infection after a baby tooth fell out and died of sepsis. Scientists even found a woman who died of vitamin A poisoning. Maybe she binged on animal liver. I don't know about you, but I'm feeling pretty lucky that I live in the present. 800,000 years ago. Then, 800,000 years ago, early humans learned a new valuable skill. Not only would this change the path of history, but it would give today's dentists something to do. But more on that in a second. Humans learned to control the use of fire. This meant we could keep ourselves warm, scare off predators, and cook meat. With humans eating more meat, this caused our most important organ to grow larger: the brain. But there was a downside to all this new delicious cooked food. It was now softer and easier to eat. This led to humans needing to chew less and our jaws becoming smaller. And a smaller jaw means we were more likely to have crooked teeth due to crowding. Take a look at this caveman's teeth. Yeah, perfectly straight because of the larger jaw size. 400,000 years ago. Okay, now that humans had fire and food, they were looking for a better form of shelter. They didn't want to live in dark and dingy caves any longer. They decided to start building houses. Now, the oldest building we have a record of is from 400,000 years ago, located in France. This is also when Homo heidelbergensis enters the picture. They're a key extinct species of human that were ancestors to Homo sapiens, Denisovans, and Neanderthals. Between 300,000 and 400,000 years ago, a group of Homo heidelbergensis moved from Africa to Eurasia. One subgroup moved west to Europe, becoming Neanderthals. Another subgroup moved east into Asia to become Denisovans. A little later, we'll tell you about interspecies romance, so keep these players in mind. Meanwhile, back in Africa, 300,000 years ago, a gradual evolutionary transition began from Homo heidelbergensis to the first of our species, Homo sapiens. In another 150,000 years, these archaic Homo sapiens further transitioned and evolved into the humans we know today. Fossil evidence helps us to see a transition in the physical features. The size and shape of the forehead, the brow ridge, and the face changed over time. Homo heidelbergensis had a more prominent brow ridge and a projecting face. Modern Homo sapiens skull was more rounded and bigger, and they also developed a higher forehead. 200,000 years ago. About 200,000 years ago, sometime in the middle of this transition from archaic to modern, a key female ancestor was born. Scientists now call her mitochondrial Eve. The DNA of each and every one of us tracks back to her. Think of her as your great-great-great-great-great-great-great-great-great-grandmother. Okay, we've got fire, shelter, and a great-grandma, but life was still hard for early humans. Anything could kill you. Diseases, a fight over a giraffe carcass, encounters with animals. In Africa, it was lions or venomous snakes. In the Asian tropics, tigers. In the Americas, cougars and jaguars. So the average life expectancy was only about 30 years. The total number of humans on Earth was probably under 1 million. 74,000 years ago. Then, 74,000 years ago, our fragile existence was threatened. A supervolcano erupted. There was a massive global climate disruption. Africa experienced increasingly dry conditions. Homo sapiens came close to being wiped out. Maybe only 600 to 10,000 adults of reproductive age survived. During this difficult time, humans seem to have broken off into smaller, isolated groups. As the area became drier, rivers shrank, but this made aquatic life easier to catch, so for a while, humans ate more fish. Ultimately, the fish may have been depleted, and this was one of the likely reasons that they left Africa. 60,000 years ago. About 60,000 years ago, modern humans began migrating out of Africa. With waters receding, new travel routes might have become more accessible. Humans first went to Asia. By 45,000 years ago, they were settled in Indonesia, Papua New Guinea, and Australia. Now, remember I said we'd tell you about romance with Denisovans? Well, in Asia, Homo sapiens mated with Denisovan populations. Denisovan DNA is 3 to 6% of the genome of specific Asian populations today. 40,000 years ago. Now, around 40,000 years ago, Homo sapiens made it to Europe using two paths. They got into Eastern Europe from Turkey, and the Mediterranean coast was another route. Here, Homo sapiens mated with Neanderthals in Europe and acquired genes related to skin and hair growth from them. Those cute freckles that you see? That's from the Neanderthals. Now, around 15,000 years ago, Homo sapiens went from Asia to North America. But how? Well, remember, the topography was different. Though today's continents were in place, a piece of land formed a bridge between Asia and North America for 5,000 years. It was called Beringia, and it connected eastern Siberia to Alaska. After making the trek to North America, some traveled down to South America. Now, this was the point in time when all other Homo species became extinct, leaving Homo sapiens as the only remaining humans left. We don't know exactly why this happened, but research suggests that it may have been due to us having better survival rates, or the other species were just outcompeted in some way. 12,000 years ago. Then, 12,000 years ago, we reached a major turning point. Humans began to master farming. They grew wild varieties of peas, lentils, and barley, and began herding goats and oxen. The first farmers lived in the Fertile Crescent, a region in the Middle East, but there wasn't just one group. Multiple, unrelated groups, isolated from each other, all pursued farming around this time. As humans became farmers, population growth picked up. By 1 AD, our population was about 170 million. In the 14th century, we were hit by the bubonic plague. It wiped out 50 million people of a worldwide population of just about 450 million. It took 2 whole centuries for Europe's population to recover to pre-plague levels. 250 years ago. 250 years ago, the Industrial Revolution began. Our world transformed from rural and agricultural to urban and industrialized. Our population started to grow rapidly. We hit 1 billion people in 1804, and in 2023, we were at 8 billion. Our growth has been exponential, but humans have needed vast amounts of energy. First, we got this from coal, then from oil and natural gas. Now, we're on the path to harvesting solar power, discovering new technology, and space travel. Now, if you're intrigued by the psychedelic mushroom theory, then, hey man, make sure to check out our other channel, Aperture. Here, we dig into more insane philosophical concepts, like how money is humanity's biggest illusion and the fundamental reality of consciousness. Okay, that's all for today's terrifying tour through the twists and turns of time. Be sure to subscribe to What If for more marathons just like this one. Thanks so much for watching, and we hope you have a safe trip back to the 21st century.